Hi, I'm Alvaro Calafell and joined with Professor Luis Sainz from the Electrical Engineering Department at Polytechnic University of Catalunya, Spain. We welcome you to our course about harmonics in electric power systems. In this first video, we will talk about power quality, relating it to harmonics. The schedule of the video will be the following. First, we will talk about quality of electric power supply, and derived from this, the concept of electric power quality and the phenomenon of harmonics will be presented. We will start with quality of electric power supply. Quality of electric power supply can be defined as the technical and commercial characteristics of power supply enforceable by the consumers and the competent authorities of the administration. These characteristics can be summarized as the following. Continuity of service, which are the number and duration of the power supply interruptions allowed. Electric power quality, which defines the voltage waveform characteristics required. And customer service quality, which include the actions of information, counseling, recruitment, reporting, and complaint. These characteristics could be compared to the quality in a supermarket. First of all, there must be a product in the supermarket. Once this is accomplished, the quality of such should be ensured. To end, the customer service from the employees should be considered. This video in particular is focused on the electric power quality. Electric power quality is the degree to which the voltage, frequency, and waveform of a power supply system conform to established specifications. Good power quality can be defined as a steady supply voltage that stays within the prescribed range, steady AC frequency close to the rated value, and smooth voltage curve waveform, which resembles a sine wave. Any perturbation which deviates the voltage waveform from its rated characteristics is a disturbance. Many of them exist, but today we will be shortly explaining some of them, focusing on harmonics. Overvoltages are produced when the voltage is greater than the normal operating voltage of a device or circuit. A voltage sag at a point in the power grid is when the voltage of one or more phases suddenly drops below a set limit and recovers after a certain time, ranging from 10 milliseconds to several seconds. Voltage transients are defined as short-duration surges of voltage and/or current in an electrical circuit which has been disturbed. A three-phase system is unbalanced and/or asymmetrical when the magnitude of the three voltages and/or currents are not equal to each other, or the relative phase shifts between them are not equal to 120. Harmonics will be introduced in the next slide. Interharmonics are frequencies of non-integer order of the fundamental frequency of the grid. In other words, they lie between two integer orders of harmonics, hence their name. Subharmonics are a type of interharmonic with frequencies lower than the fundamental. Flicker is the impression of instability of visual sensation due to a light stimulus in which the brightness or spectral distribution fluctuates over time. Frequency oscillations are the deviations from the nominal value of the fundamental frequency of the power system. Next, we will be introducing harmonics. Harmonics are voltage disturbances which cause a deviation of the supply voltage from its sinusoidal waveform. A sinusoidal waveform is distorted in the presence of harmonics. In future videos, we will go through the following index. First, we will present harmonics and their origin. Next, we will quantify the harmonic problem. After that, we will present the harmonic impact on electrical installations, and we will explain how to solve the problems harmonics present.